Hey everyone, and welcome. So, if you're in the social sciences, let me ask you, what's the single most important mathematical tool you'll ever learn? Well, a lot of people would say it's linear algebra. And today we're diving into its absolute cornerstone, the matrix. I mean, think about it. We are practically drowning in data these days, right? From economics to sociology, it's everywhere. And the real challenge isn't just getting the data, it's figuring out how to organize it so you can actually see what's going on. So how in the world do you do that? Okay, let's make this super concrete with a classic example. We're going to look at a really common problem, trying to keep track of a bunch of different categories of information without it turning into a complete tangled mess. Let's say you're a car dealership and you're tracking your sales for January. You sell trucks and passenger cars, and they come in red and blue. Now, if you write it out like this in a simple list, sure, you can read it. But what if you had 10 vehicle types and 12 different colors? That list would become an absolute nightmare to sort through. And this, my friends, is where the pure elegance of math steps in. Let's see how we can take this jumble of data and build it into something much, much cleaner. So what even is a matrix? Well, at its heart, it's just a rectangular grid of numbers, like a spreadsheet. But this simple little structure is unbelievably powerful. It lets us organize data with lots of categories, and, as you're about to see, it lets us do calculations on all of that data at the same time. And boom, look at that. It is the exact same data, but now it's beautifully organized. The rows tell you the color, the columns tell you the vehicle type. In a split second, you know you sold 15 red trucks. It's clean, it's efficient, and it's powerful. That is a matrix. Okay, so we've got our data organized. That's great. But now, for the fun part, let's actually use it. A matrix isn't just for looking pretty, it's a tool we can use for some serious calculation. So here's a real-world business question for you. We've got our January sales all neat and tidy, but what about February? How can we easily combine the two to see our total sales for the year so far? All right, so here's our January sales matrix again. Let's just call it matrix J for short. And now, here comes February's data, which we'll call matrix F. Looks like sales were a little different that month. Okay, so how do we put these two together? Well, the process is actually incredibly simple, just the way we like it. First, you just have to make sure the matrices are the exact same size, and in our case, yep, they're both 2 by 2. Then you literally just add the numbers that are in the same spots. And there you have it, our new total sales matrix. To get the total red trucks sold, we just added January's 15 to February's 12, which gives us 27. We do the same thing for every other spot. And just like that, in a matter of seconds, we have a complete picture of sales for both months. Now, there is one big rule you absolutely cannot forget. This whole thing only works if the matrices have the exact same dimensions. You can't add a 2 by 2 matrix to, say, a 3 by 4 matrix. It just wouldn't make sense, because the categories wouldn't line up. Okay, let's try another super common scenario. The dealership had a fantastic January, and now management wants to set a really ambitious goal for next month. Double the sales of everything across the board. So, we start again with our January matrix. How can we possibly double every single one of these numbers, all at once, without a bunch of tedious work? We do this with something called scalar multiplication. And scalar is really just a fancy math word for a single number. That's it. In this case, our scalar is just 2. And here's the result. All we do is multiply every single number inside that matrix by our scalar, 2. So 15 becomes 30, 20 becomes 40, and so on. In an instant, we've got our sales projection for the next month. It is that fast. So, we've seen how to organize our data and do some pretty cool basic math with it. But let's zoom out for a second. Why is this stuff so important for, serious quantitative research? Here's the big picture. Matrices don't just organize information. They let us do huge calculations on entire data sets all at once. This is the absolute bedrock of more advanced methods like linear regression. That tool social scientists use for everything, like finding the relationship between poverty levels and crime rates. And hey, don't just take my word for it. This idea is repeated all across the field. If you want to understand modern quantitative analysis, you have to understand matrices. It's basically the language that data speaks. It's non-negotiable. So, we've learned how to add matrices and multiply them by a single number. But what if you needed to go backwards? What if you had the final answer and needed to solve for the matrix you started with? That question right there leads us straight into the next crucial topics in linear algebra, matrix inverses and determinants. But for now, you've got the fundamentals down. Thanks for tuning in.